welcome to my Tech Fun. A few weeks ago I was contacted by Gearbest if I would like to do a review of the Ortur Laser Master, and this is not typical video you will see on this channel, but I said yes because I like some experimenting. So now here it is, and I will do some unboxing and some testing of this laser engraver. First let's see the parameters. Ortur Laser Master is a 15 watt laser engraver and cutter, and it's portable because it's really small and compact, and it is very easy to operate. And it has built-in G sensor, and this means if machine tilts, then automatically it stops the laser work, which is good for safety, of course. But unfortunately I was hoping that because it's portable I can put it, for example, in vertical position to some furniture or door or something like that to do some engraving, but I think this will not work because of this G sensor. I will test it, but okay, it says PWM power regulation, so this means we can regulate the power, reduce the power if necessary to create for some grayscale image or something like that. What is important to mention, LaserGRBL is included with the provided software, but you can download it from their website because it's free open source software. And it is important to mention that the engraving area is 160 by 150 millimeters. You can see here the image format supported by GRBL. Operating system is Windows. For Mac or Linux users, probably Lightburn will be the solution. I will check that later. And yes, this is useful information to see what can you engraving or cutting with the 15 watt laser. There are some safety instructions here, and you can see some other specifications here in this table. Okay, let's see content of the box. I really like this kind of packaging, so every main part is separated. We have here some safety instructions. This is very important table, reference table of engraving power and speed for different materials. So this is very useful information for testing. On the other side of this paper is the part list. And we have user manual, well, actually on the link so you can download it. Let's see the hardware. This is Y-axis, safety goggles, power adapter, brush, acrylic plate, screws and washer, USB cable. This is the laser module, and this is the X-axis. Just for comparison, this is 1 watt laser, because I'm building one Arduino based laser engraver, and this is 15 watt laser. Okay, so I don't have user manual, but it is available online. So if you go to that link, you can download not only the manual but every other file from the Dropbox. And I will go page by page for this user manual, so even if you don't want to download it, you can see here if you stop the video on a certain page. And now let's see the assembling. Okay, first step is to place the laser module to the module holder with only 2 screws, so it will be attached here from the opposite side. So it's adjustable. I will adjust it later. So then I have to plug the laser module cable into port of the pinboard. Okay. So next step is to place this hole on these 4 screws. This is the X-axis and goes onto Y-axis. This is the space for the cable. Okay. to fix it into place. I don't like to tie too much because it has some plastic spacers below. Next is to use this plastic cable tie to ensure the laser model cable. So the head, I will place it here and go around. Try not to cover with my hands. I will cut this later. Then I have to plug the X motor cable into the stepper motor. Okay, only one way to put it. And now we have to install the drivers. Now between those files only drivers for Windows can be found. For Mac users maybe the Lightburn is the solution, so if I open here we have this link and it says it's paid software. I checked this website and yes, there is a list, so Mac OS and Linux are supported, but it is paid software. Back to Windows drivers. Double click and just confirm and go over the procedure of the installation, and after a few seconds drivers will be installed. And now we have to install the GRBL, LaserGRBL software. Between software we have the 3.0 version, but I like to use the latest version. Since this is open source free software, I go to website and download the latest version and go quickly through the installation process. By default it's Hungarian now, so I changed it into English, but it needs a restart. Now I am placing a silicone soldering plate just for safety, and now I am plugging the power and connecting the USB with the laptop. And long press to turn on the machine. Click the connect and unlock. So with these buttons in bottom left corner we can manually move the module, but I notice a small problem. So there is a problem with the y-axis. Its motor is rotating, but this is too loose, so I have to tighten this belt. Now let's turn it in the proper position, because cables are on the back side and the logo is on the front side. Okay, just one more test for moving. Yes, the belt is now working correctly. Okay, so this was the manual movement. I have to add some buttons here. Right click and import custom buttons, and you have to find those between those files, the custom buttons which you downloaded from their website. And it's time for first test engraving. First, always use these safety goggles to protect your eyes, because it can be very dangerous. Now by clicking to this button we can enable the laser with the low power, so we can set the focus. It's turning a little bit hard, so I have to turn this button until I get the smallest spot here on the test probe. Second method is to move the module itself up and down, but be careful, don't tighten it in under the angle, because the dot will be elliptical. Or the third solution is to put something below the legs to raise it if you want the same size part to engrave. Let's prepare some image. So in my test probe will be 4 by 1 centimeter and set 300 dots per inch. And just enter some text for testing. save it as a JPEG, and import into LaserGRBL software. Now we have here a lot of things to set. So you can use line-to-line tracing, black and white, vectorial, or center lines. So we will play with this later. Brightness and contrast I don't have to set up because it's already black and white, and I can see that it recognizes the size of the part because it's 300 dpi dot per inch. And now very useful button is this border. So if we click it, then it will go with the low power to draw a border so we can see is our workpiece on proper position. So we can move it by hand. I can move with the buttons and then set new home point with this button here. Now let's check the borders. Okay. Safety goggles. This is real-time speed, so you can see how fast you can engrave some smaller text. And it's finished. Wow, this was very quick. Okay, let's burn some other things. I want to engrave some grayscale images, so I need first some experimenting. I will create one image from black to white, and I will mark the end with this black line. And in first test I will use line-to-line tracing. And I will do on plywood. Three by 1 centimeter. Testing the position with boundary and start engraving. Not too good for grayscale because it's very sharp edge between this and this line, so we have only a few lines of between grays. So if I would engrave some grayscale image, approximately this is how would it look like. So in my next experiment I'm using black and white dithering. But as you can see, nothing below maybe 15 or 20% will be seen. And above, I think this is 55 or 60%, everything will be in black. So only here we have some grayscale. And then I decide to create a rasterized image myself. So I'm using this option in Photoshop. So these rasters are created by me, and now let's see the results. Now I have some gray color even here, so I think I should print my grayscale photo. I think you will recognize who is it. And don't worry about me, I have two glasses, one is for camera, the other is for me. Can you recognize her? You can write me in the comment. And it's time for cutting. I created one test image 10 by 10 millimeters. And again here I have option for plywood cutting 1.5 millimeter. Actually it was 1.7. This was real-time cutting. Millimeters. And just quick testing of the dimensions. So these are outer dimensions of the cut and pieces, and these are inner dimensions. So approximately 0.5 millimeter is lost. This is now PETG. Unfortunately, nothing visible here. This is PLA. Let's see what we will have here. Well, hardly visible melted line, but no, we cannot engrave PLA. It's a pity. In this experiment I was curious how it will engrave if it goes out of the focus. So this is cardboard with diameter of 5 centimeters. And surprising, but it looks really good, except the letter N, it was really out of the focus. Cardboard. Next is cutting of the cardboard. It was 3 millimeter cardboard. One pass was not enough. Then I tried with 2 passes. Still nothing on the other side. And then with 3 passes, finally it was cut completely. Now it goes through. Let's try to engrave this business card. So I needed 2 passes to cut completely this business card. 2 passes. I'm just checking mark of this silicone. Silicone can handle very big temperature. This is for soldering. And now let's try to engrave some business card. This was too fast, and then I created another one, slowed down. 3000 millimeters per minute, 1000 millimeters per minute. For me it was very important to find a solution to import files for Fusion 360 into LaserGRBL. And this is my solution. So first we have to install the add-in named shaper. And after installing we can create some shape, for example a spurger. And click on the shape you want to import, click on the shaper button and save it as SVG file. And this SVG file we can import into LaserGRBL, and we can choose the material we want to cut. Always check the boundaries before you start cutting. And now this is the cutting from plywood, just for experimenting. This is speed up 8 times. Creating a shaft hole, and here it is, laser cutting gear. I should add some offset, for example 0.2 millimeters, because it has some weight in the cutting. Just quickly checking, is my silicone pad damaged, but it's not. Okay, let's add the shaft, which is actually just M3 bolt. And since they has the same modulus, it can work with other M2 gears. And since I work at the food engineering department, I wanted to engrave some food, just for fun and curiosity, nothing else. I started with a lemon. Nothing on the lemon. Engraving egg, with some kind of middle success. Something is visible, not much, but... Trying to engrave bread, because I saw this video on the Gearbest website, but without success. Nothing. I'm a little bit disappointed because I tried to reproduce this video. Let's try the other side. And then I tried the other side with some kind of middle success, but not too nice. It's not too visible, but it has good smell. It's a smell of the fresh toast bread. Then I try to engrave some cookies. Plasma cakes from Serbia. Smells good. Looks very nice. Fresh. Engraving some meat without success. Nothing. So it smells good, but nothing is visible on it. Pity. And it tastes good. Between provided documents there are some tips, and I saw that well, it was of stainless steel, that if we cover it with the marker, then we can engrave it, but unfortunately without success. Well, this was not real stainless steel, but it was steel. Nothing. Pity. I'm testing now the G sensor, because theoretically if I tilt it, it should stop engraving. It stopped now. Okay, so it needs very weak tilting. This test you shouldn't try at home. Since it is small and portable, I was curious, can I attach it to some vertical surface, like door or furniture, to engrave it. My test was successful, but I'm not sure why G-sensor allowed this, but it worked. The biggest problem is that if stepper motor is not active, module will move slowly down. And this is a problem because if you set the homing and check the boundaries, and if it slowly moves down before you start engraving, it will do the engraving in some lower position. So I don't really recommend this method. And of course it's not even designed for this. If the stepper motor would be active between the homing and the starting of the engraving, then this method could work. And this would be a very big advantage compared to those desktop engravers where you have to place inside the work object. So when the stepper motor is not active, it cannot hold the module in one place. With this, it's not a problem because it's in vertical. But here it's not working. So it will do the engrave, but be very careful. Probably it will not start from the correct homing point. So this, I don't recommend to try this setup. It's not even planned for this. Okay, back to horizontal position. The conclusions. I wanted to try a lot of materials, but unfortunately this video is too long anyway. I don't have experience with this kind of review so far. A good way to start is the reference table provided by Ortur. The second help is inside the GRBL itself, because they are predefined materials with the engraving or cutting speed and laser strength. About this 15 watt laser, that's the consumption power, so laser is actually weaker. Anyway, it's strong laser, so you have to take care about safety. Don't put your hand below the laser, always wear a safety goggles, that's very important. And be careful not to burn anything, so always be there, don't leave the engraver without supervising. About the price, it's a little bit below $200. I will place an affiliate link down in the description, so you can check the price, which doesn't cost you more, but it can support my channel. I started to building one Arduino based engraver for myself. I already bought most of the parts, and it cost me $90 so far, but only with the 1 watt laser. Then I noticed it would be good to have some limit switches for homing, and I didn't even start with the 3D printed parts. So this engraver is basically in only 5 or 6 pieces, which you can put together in 5 or 10 minutes, and after installing the GRBL software you can start engraving. And the small size and portability have a lot of hidden features in itself, like engraving in vertical position, which I don't recommend so far, unless you know what you are doing. The G sensor and tilting, it is good to build in for the safety reason, but I think it should be a little bit more sensitive, because you saw, and I'm a little bit confused, why could I print in vertical position if that the G sensor is built in? If you know the answer, write me in the comments, please. If you need a laser engraver and you can fit into this size, then I highly recommend this product. That would be it. I wasn't paid to create this review, but I can keep this laser engraver, but this is really my true opinion. I hope it was useful. Thank you for watching, and happy engraving and cutting.